So in this video, I want to explain how the ESP is being programmed, a little bit about the storage on the ESP32, the bootloader, the UF2 part of it, and generally how you program it using some of these different concepts. So the first thing we have to start with is understanding that the storage, the flash drive on the ESP32 is divided into different parts, hence the partition table. It's the same on a normal Windows computer or Mac computer. They also have a partition table, and typically you would have like on a Windows PC, you could have a hard disk that was very big, and you divide it into a drive C and a drive D, and that's is done in the partition table. So similar here, we have a partition table, and it's the storage for the whole device. So it's 4 megabyte on the older ESP32, and the new ESP32-S3, it's 8 megabyte. So here it's just examples of the partition table. Here it's a 4 megabyte, and in the first part of the bootloader, the first part of the partition here, we have the bootloader. And the bootloader is hard-coded into this thing here, so it can always kind of like be recovered. You can't overwrite the bootloader because then you couldn't write a program into it again. In the old days, on a Windows computer, it's still called the BIOS, so basic input-output system. In computers back in the 70s, 80s, you had like a read-only memory where you had stored that kind of data that couldn't be overwritten. The next part here is a non-volatile storage. So there you will put, for example, data that not hard-coded, like you will just write that in your application. But if you have data you want to change between each time you boot up your device, such as, for example, a date when the last was booted up, or like a boot count that you add every time it boots, you have a boot count and things like that. That could be interesting, for example, if you have an unmanned solution and you want to know if you have power failures, then you can see if you have a boot count of 5, maybe it was actually had 4 power failures in the meantime. Then you have the over-the-air data, so that's a pointer. I'm going to talk about that in a later slide, but it sits there. And then you have your Wi-Fi data, the physical information about your Wi-Fi. So there is a MAC address you can't change, so that's also logged in here. And then you have your app. So here I say your application version 1, and you have version 2 and version 3. And the over-the-air data early on is a pointer that points to which of the 3 applications. So similar to your Windows computer Mac, you can have multiple applications that can't run at the same time. And the way it works here and meant for here is that you have one app running. So let's say they're version 1. And then when an update comes over the air, so that you put into your program, you say you want to connect to this website and see if there's a new app. If it's there, you download it, but you download it into another slot. So for example, OTA 0. And then if everything goes fine, there's no power failure or anything else in the meantime, the app is there, and you verified that the data is correct, then the pointer changed to OTA 0. So here's an example of these partition for the ESP32. So they are comma-separated files, and you can make your own, but there's a lot of them already made. And depending on what you want to do, you want to allocate the data different. So let's look at the default one. So here we have the NVS. So you can see the bootloader and the Wi-Fi thing and things like that is not in the table because you can't change it anyhow. So you have the boot count or whatever you want to store in your non-volatile storage. Then you have your pointer to either app 0, app 1. In the previous example, there was like 3 slots, but normally you will only have max 2 slots. And then you have your you have a storage here that's called SPI FFS. So this is a storage system. So instead of you read and write to SD card, with very little change, you can then read and write in your program to a storage on the drive here. But you can see here, this is 1.51 megabyte, and you have a SD card you plug in at 32 gigabytes. So, it's only if you're in a situation where you can't have a SD card for whatever reason, and you don't need to write a lot of data, then you can store it like that. So the pointer here is to app 0 or app 1. So when you download it, when you program it using the USB or PPU, then it always goes into app 0. But once you have it out there in the field and you do your over-the-air update, then it will every second time swap between app 0 and app 1, and the OTA data will then point to the right one. So when it starts up, it will start up in the latest functional app you have. So you can see below is something that's called no OTA. So there's still a OTA data, there's still NVS, and there's only one slot for the app. But now, instead of you only had 1.31 megabyte, now you have, like for example, in this example, 2.1 megabyte. And you have also more space for data, the SPI FFS, like 2 megabyte. Or, as you can see in the top one, there's one that's called Huge App, where they still only have one no OTA, but now they have 3 megabyte for the application and only 1 megabyte for SPI FFS storage. In Arduino, when you go into tools and select your ESP32 and you select these like upload speed and port and things like that, then you can go into partition scheme here, and you can see there's a lot of them already. There's also something called custom in the bottom, but here is a number of different partitions. Normally, for most of us, and I say most being 99.9% of people using Arduino and things like that, they just use the default. So the default here has 1.2 megabyte for an app. Remember, it's 2 times. So that becomes, of course, 2.4 and then 1.5 for SPIFS. And then there's 0.1 megabyte left for the loose. So that's a default if you don't change anything with points there. And that's what you can use on the old core, the CWV4 and the CWA 1, version 1, which is the one with the ESP32, the one with the big module on. If you have the new core, you can set it to 8 megabytes. And then, of course, you have 3 megabyte apps times 2 and 1.5 megabyte for SPIFS. And that's on the new core. And all I'm talking about here is also how the button works, because it's only on the new core you have the UF2 and these different programming things and the bottom and things like that. It's not default on 8 megabyte, and if you don't do it, well, then you have 1.2 megabyte, but I don't think I made any programs that are so big so I need anything else. But there will be situations, for example, if you use the camera on the old core, then you have to say you have a huge app, because the whole camera software and things like that takes up a lot of space. So there you set it to 3 megabyte, or you point to this huge app, and then you can use the camera on the old core. So let me then kind of illustrate it for the purpose of how you use it. And then after that, I'm going to demonstrate it. So you have the native bootloader, the thing that in the other slides was called the bootloader, the stuff you can't change, marked here in red, it's there. And then when you program it in Arduino, then you just actually program it on top of this bootloader. Of course, there's a few other files and systems and things like that, but you don't have to focus on that, and I'm not going to focus on it here. So that's the normal Arduino mode. Then you have this UF2 mode where we put another bootloader on. So you still have the native bootloader, and then we put the UF2 bootloader on. And when we put that on and you plug it into your computer, it looks like a thumb drive. And then the UF2 files that we provide, you can simply drag and drop them to this thing here. You don't have to have any app to program and things like that. So therefore, we provided this thing here with the UF2 bootloader on. So if you want to install some of the apps we provide, like the sample application, or like MicroPython, or we have like a app to see what the I2C things you installed, I2C scanner, and so on. I'm going to show that in a demo. Then you plug it in, and you can drag and drop or save it straight to this drive here without using any other tool. So there it's your UF2 comes on top. It's not like half the size. The text is not to scale, let's put it this way. The UF2 bootloader also takes no space. So you still have almost the same amount of space for this thing here, but it's just an easier way for us to kind of distribute the software without installing anything special. So the way you kind of like change between all this thing here is you have two buttons. You have the play button and you have the reset button. And I'm going to demonstrate this thing here on a small core, but it's the same on the ISS core or whatever other core you have. That uses the ESP32-S3. So the new CWA version 2, or the Nanoracks ISS core, which is the kind of like the narrow one, also have these two buttons on. So this is for those cores here. So when you want to use the native bootloader, the way you do it is you click on the play button and hold it down, and then you give a short click on the reset button, and then you release the play button, and then it's in native bootloader mode. And you know that because the LED is steady red on your core. So you will see a steady red LED. And I say steady because when you use an oil, you will see not a steady LED, but a pulsing LED. So steady means it's just on, it doesn't blink, it's just solid on. Then if you have the UF2 bootloader installed, so remember the native bootloader always works, it's always there. But the UF2 bootloader you have to install. It comes installed, but if you override it because you in Arduino override it, like I'm showing an example here, then of course you have to reinstall it afterwards. It's quite simple, but then you have to install it before you can then install the UF2 programs. Once it's installed, you activate it by double-clicking on the reset button. If you have installed it and you haven't actually have any apps on it, it's always in this mode where you will see a pulsing red LED. On the native bootloader, when you have a steady red LED, if you had like something where the green LED turned on or something like that, on a color turned on, and you then put in bootloader on, it will not switch off the green. So what I'm trying to say with that, it's just the red LED that's stated that counts. The color of the other LED, of it's on or off or whatever, doesn't matter. If you use the UF2 bootloader, what happens is that it will have a pulsing red LED, and then if you connect it to your computer, which the idea here, then you will have a green LED. But you can also connect it to, say, a power bank. And if you connect it to a power bank, you will have a pulsing red LED, and the other LED will be red, indicating it's not connected to a computer. Okay, let's do a demo here. So on the screen here on the right, I have a Chrome browser open, and I have this apps.maxiq.space that allows you to install the bootloader, but you can also install some of the apps we have listed below using this site here. Then on the left-hand side, I have Arduino open. I minimized it a bit, and I have opened the example that's called ASCII table, just so it writes out to the console, just to demonstrate that, because it's the important part here is to kind of like figure out what is happening with the USB, and I can't see it, and sometimes I can see it, I can't program it to it. And then I have below the Arduino here, I have my folder where I can see when my when my core appears as a drive. And if it appears as a drive, it'll show it as a CWA. So I can see the drive is there. And then I have in the middle here, I just have a little terminal where I can actually see what I'm running. And then, of course, here on the screen, also in the middle of the screen here, I have my core. So right now, it's it just have been booting up its normal app, and the normal app is a starter kit. And the starter kit, if I reset it here, and I'm not doing it yet, but if I reset it here, it will just boot up. So before I do that, I'm gonna open the my serial monitor here, and I'm just gonna clean out the serial monitor. And then what I'm gonna do is I'm gonna press reset once, which just is the same as power cycle it. I can plug it in and out. I can press reset once. So if I do that, you can see that it haven't been able to connect to any of the sensors, as you can see. And the red LED is not pulsing, it's blinking. And it's simply just something I have put into the starter application to tell it's in startup mode. But you can see on the screen in the serial monitor here that it has run something, and its IP address and the config portal are running. So the app is running. If you had the display plugged in and things like that, you will just see that. So that means that we have the starter application installed, and we installed it as a UF2. So now I can go in and by the way, in order to see this thing here, I'm gonna just show in tools that my port is called USB modem 2101. On your Windows computer, it's called a number like 3517, whatever. Here we can see that it also says ESP32 family device. You're probably not getting that information on Windows. And the two other here, don't worry about that. That's Bluetooth and some other stuff here. But the USB is this one here. And another way I can see it, of course, I can run a command for Mac. And then I can see here that my USB modem is called this thing here. So what I can do now is that I can either go into native bootloader mode, and then I can just program it in Arduino, or I can actually install another app using the UF2 bootloader mode. So if I want to go into UF2 bootloader mode, I double click on the reset, not too fast, so like that. And you can now see that I have a pulsing red LED. So it's kind of like fading in and out. And I have a green LED. It might be overpowering the screen here a little bit, but if you try it yourself, you'll be able to see that. Now, when I'm in that mode here, you can also see on my screen here on the folder that I now have a CWA drive here. So that is a drive where I can actually put an application on it, okay? And then over here, if I go into either this one, and say, okay, what's the drive? And now you can see the USB modem and call something else. And I can't actually access it. It does say there is a drive here. I don't know if what we'll do in Windows, but you can see here, I don't have this drive anymore. I have another drive. So this is to indicate that now it's in this mode here, and you can't actually program it from Arduino in this mode here because this is confusing it. So what you have to do is if you wanted to program in Arduino, you have to put it into native bootloader mode. But I'm gonna do that just now. But once in this mode here, you can take any of these apps below here and say, I'm gonna install that, okay? Now, the easiest way to do that is you go here and right click and say save link as, and then you get a place where you can save it. In this case here, it chooses the drive CWA. So I say save, and then you can see here it flashes because now it's busy programming using the UF2 bootloader. And now it's finished, and the red blinking LED, remember that's my app. And if I actually had cleared out this thing here, and you can see it's not necessarily connected over here because because I was in this other mode. Okay, now the CWA drive had disappeared because it's actually running this thing here. So it's running the app. It's not in any bootloader mode, not in a UF2 bootloader mode, and it's not in the native bootloader mode. So I can say reset here, and then you can see it comes up here with the text, and the thing here blinks again. Okay. Now what we're going to do now is we're going to show how to then program it in Arduino. So in order to program it, if I program it now and I try to, for example, select, okay, now I can select this file here. So I could program it properly now. But the thing is that let's double click here. So we're now in, So now we're in UF2 bootloader mode. And if I go here and then select that folder, or that USB drive, and then try to install it, I shouldn't be able to install it. So now it's compiling, and remember the app is just whatever app. I just took the ASCII table, so it writes out to the serial monitor, and then it does the compilation, and it's doing the uploading, and then it tries to connect to that serial port, or this USB port with a long name here, and it fails to kind of like upload. So you can see here, it tried to connect to this long name here, and it fails to upload. So I have to put it in native bootloader mode, okay? So the way I do that is that I click on the play button and then and hold it down and then reset. With a little dexterity, you can actually, with your thumb, hold down on one side, roll over to the reset and let go. Now you can see the green is still on because it was on from the other stuff. That doesn't matter, it could be off, whatever, but the red light is now steady red. So now it's in bootloader mode, okay? And now we can go over here and we can try then compiling. Before we do that, we had selected before the other drive. Now we go back and select the 2101 here. And then I say program, and then we should succeed in programming this now. Now, it's a little different, but if you put it manually in bootloader mode, bootloader mode, you should also reset it manually. And there's also, once you program it like this in here, where you put it in this mode here, and now you can see here, if I go to the serial monitor here, it printed out the ASCII table, okay? Now the green light is still on because, I haven't turned it off anything like that. So in order to do that, I'm just taking it in and out here, and you can see the green light doesn't come on. And if I clean the serial here and I press reset, then you can see that it runs this app again. So now I'm in this mode here. So if I try to double click on the reset, nothing happens. It actually just works as reset, and it will just restart the app. So I don't have the UF2 bootloader. So now if I want to program it again, so if I take, for example, a line here, and I say, no, I just leave it like that, but I just program it again. I haven't put in a bootloader, but because it's actually been programmed already by Arduino and it's not confused by what was lying there already, you should just be able to program it again without putting into bootloader mode. It will put it into bootloader mode itself. As you can see, that red light comes on and it's writing the data, and now it's uploaded and it ran the app. So it will just work fine like that without next time. Now, if you want to get back to the UF2, then remember you have to switch off the cell monitor here. So you switch the monitor off, because otherwise other apps cannot, like the apps.maxiq.space Chrome cannot access it because it's locked because of the cell monitor here. So here, over here, we then have to install this thing here. And again, in order to install it, if there was something that didn't work, we put it into native bootloader mode in order to install the UF2 bootloader. So I'm going to do that here, but you could probably also, as I say here in the description, if the connection is troublesome, then put it into bootloader mode. So what I'm doing is that I'm putting it into bootloader mode, just to be sure. And then I click install here, and it comes up and say, what's it to connect to? Remember, I have these two other ports. So obviously this one here, first time you do it, it will say, do you want to pair? I have already paired it, so I say connect. And then it connects to this thing here, and it succeeds. So now we install. I can erase the device first, and then I install the bootloader. So this time there's no blinking or anything like that, because it program is similar to Arduino will have done it. So it doesn't know the configuration of the device or anything like that. And you can see here, it puts it in and it says wrapping up. Now, the thing is that when it comes to this side here, it doesn't reset it automatically. So I can reset it. And when I reset it like this thing here, you can see it's now in UF2 bootloader mode. And there's no app on it, so if I reset it again, it doesn't run anything because there's nothing there. So now it's in UF2 bootloader mode, and I can go in and look at console, but I don't want to tear from this thing here. If I want to then put the starter kit on, now it's in this mode here. I simply just, in this mode, it goes automatically if I double click on reset. And in this case here, there's nothing else, so it will just do that. So I can now go in here and say save link as, and then it comes up and I choose the CWA drive that you can see over here. It's already ready, and I put it in, and now you can see it's programming here, the lights here, and that takes a little while, and there's now been programmed, and now it runs. So over here, I can then say, okay, show me the cell monitor. And just to make sure I can see the data, I'm just resetting the program, and you can see here in the cell monitor that it says that it can't find any of the sensors, but otherwise it's like running fine. So I hope this thing here kind of like illustrated the different modes here. If it's not unclear, something like that, let me know, and I might update this video here in a later stage. Thank you very much.